Alright, solve for x in each of the following. So guys, I've just written that inequality there. Do we notice that it looks like an equation, right? 9x plus 4, and then we have a 3x on the other side. Guys, this symbol means that the left-hand side, whatever is written on the left-hand side of that symbol, has to be bigger than or greater than whatever is written on the right. So when we are solving an equation, when we have an equals there in between the two sides, we need to find a value of x that will make the two sides equal to each other, right? So that if I sub in x on the one side and x on the other side, I'll get the same value on both sides. In this case, guys, we are actually going to get more than one answer, okay? Because the two sides, thank you, are not meant to be equal. This side is just meant to be a bigger number than what we're getting on the other side. Okay, so for example, if x is 1, I'm just going to write here on the side. If x is equal to 1, what would we get on the left? If I sub in x equals 1, I'm going to say 9 times 1 plus 4, right? So 9 times 1 plus 4, what's that? 13. Okay, now if I sub in x equals 1 on the right-hand side, am I going to get a number that is smaller? Let's see. If I say RHS, 3 times 1, right, 3x would be 3. Guys, do we all agree that 13 is in fact greater than, bigger than 3? Right? So x equals 1 would be a possible solution. But guys, x equals 2 would also work. Okay? X equals 3 would also work. So there are going to be multiple x values that will give us a left-hand side that is bigger than the right-hand side. Now, we're not going to test a whole bunch of values, okay, because that's going to take forever. What we're going to do here is we're going to solve it exactly like we would solve an equation. So we're going to get all the x's on the one side and all the numbers on the other side. All right, so what is the opposite of having a positive 3x or adding 3x? Subtracting 3x, hey? So I'm going to say on the left, 9x minus 3x. You don't have to write this step down if you don't want to. I'm just showing you exactly what I'm doing. And that 4 I need to take to the other side. It's adding 4 here, so on the other side I'm going to have to subtract 4. Just like an equation. Okay, what is 9x minus 3x? 6x. So I have that 6x must be greater than negative 4. Guys, what is the opposite of multiplying by 6? Dividing by 6. So x has to be greater than negative 4 over 6. Is that its simplest form? No. I have to still simplify that to 2 over 3. Alright, how do I get that? 2 can divide into both 4 and 6. Alright, so I'll just write that on the side for you. So guys, what this means is that x can be any number that is bigger than negative 2 over 3. So for example, we said 1, right? But what other number can we think of that is bigger than negative 2 over 3? What about 0? Will 0 also work? Let's see. 9 times 0 is 0 plus 4 is 4, right? If x is 0, I'm testing now, then I would have a 4 on the left-hand side. And if x is 0, what would I have on the right?
0.
A 0, which is true, right? 4 is greater than 0. So what this answer means, guys, is that it's giving us a range of solutions. Lots of different solutions. So x can be any number that is greater than or bigger than, you can decide, it doesn't matter, negative 2 over 3. Now guys, the notation that my answer is written in here is called inequality notation. So just write that underneath, please. If they say that you must leave your answer in inequality notation, then this is the notation that you need to use. Alright, but I'm also going to write this in interval notation. That is like the notation that we used with the trig graphs, right? Where you say x is an element of, and then you write your values. Guys, can we stop talking there on the side, please? So just another notation. You would say x is an element of, now guys, with interval notation, you always have to write the smallest number first. Alright, so you have to like read it as if you're reading off a number line. So here we're saying that x has to be any number that is bigger than negative 2 over 3. So do we agree that the smallest number here is going to be negative 2 over 3? It can be anything bigger than that, right? So it can be 0, 1, 2, 3, 4, whatever. And can it be equal to negative 2 over 3? Okay? No, there's no line there. Okay. If there was a line underneath this, then that would mean that x can be greater than negative 2 over 3, but also equal to. Okay, so because it's not equal to, that actual value is excluded. So that's why we're using a round bracket there. We're going to say negative 2 over 3. That's the smallest value in this interval. And then, guys, if it can be any number bigger than negative 2 over 3, is there any limit on that? No. Okay, so we're going to say infinity, and then again a round bracket for that. So I'm just going to make some notes here. That round bracket, because cannot be equal to negative 2 over 3. And guys, that will be given in the question. Okay, if in the question there was a line underneath that symbol, then it could be equal to. Yeah. Yes, it is. Yeah, I'll write it now. Okay, and then for infinity also here, we always use a round bracket for infinity, guys, because I think I did explain this before, but I'll just say again, infinity is not an actual number. All right, so you can never actually get an answer that's equal to infinity. So infinity is not an actual number, therefore x cannot ever be equal to infinity. All right, and just the name of this notation, this was interval notation. And then just the last one that you need to know, set builder notation is nice to know, but they don't actually ever test that. So I'm not going to spend time on that one. We do need to know inequality notation and interval notation and then number line. Okay. Saskia, have you gone to the bathroom? Do you, yeah? Sorry, she asked. Okay, the other one that you need to know, guys, is number line notation or just number line. It should be underneath here.
Thank you.
Now, since we only have one value here, that is the only value that we're going to put on our number line. If we had 2, we would put 2, right? So I usually just put that value in the middle, and then you're going to have your negative 2 over 3. You must just label that value as it is. Now, guys, can it be equal to negative 2 over 3? No, so we use an open circle. All right, so just like an open dot like that. And now our arrow needs to indicate, must our values be below negative 2 over 3 or must they be above negative 2 over 3? What do we think? What is the same? Above. Hey, greater than. So we are then going to draw an arrow going from negative 2 over 3. And because it can go to infinity, we need to put an arrow on the end of that line. Okay, and this obviously is number line. Guys, if they don't say anything about notation in the question, so if they're just saying solve for x, then you can stop here. All right, then you just get to the line where you have your x on the one side, you have your symbol, and you have a value. Or you'll see we're going to do some questions where you have 2 values, one on either side, but then you would stop here. Okay, but sometimes they say express your answer or write your answer in interval notation as well. Then you would add that. Okay, it just depends on the question. All right, are there any questions on that one? Okay. Let's look at another one, number 2. Oh, sorry, that should be a minus. All right, this one is obviously a bit more complicated than the one that we started with. What do you guys want to do first? Multiply out the bracket. Okay, we can do that. So we're going to leave what we have on the left-hand side just as it is. So it's 2x minus 3 over 2. Now, guys, this symbol now is saying greater than or equal to. Okay, so when we do our brackets, we're going to have a square bracket for that one. I'll show you when we get to that point. And now we're going to say 3x plus 3. All right, now this is an equation or an inequality, but we know how to work with an equation with fractions. We multiply every term by the denominator, right? Or by the LCD if we had multiple fractions there. So here, the reason for that, remember, is so that we can cancel out the denominator. Okay, so the denominator is 2. So I'm going to multiply this by 2 and that term by 2 and that term by 2. Right, we did this a while ago. So now those 2's are going to cancel out. So on the left, I'm going to be left with just a 2x minus 3. So we have gotten rid of that denominator. And then on the other side, what's 3x times 2? 6x. Thank you. And then next up, 3 times 2 is then 6. Okay, now again, we need to get all our x's on the one side and all our numbers on the other side. So we have a 2x here, and this is going to become minus 6x, right? So what's 2x minus 6x? Negative 4x. We're using that same symbol. And on the other side, we're going to have a 6, and then this minus 3 is going to become plus 3. What's 6 plus 3? 9. Now guys, here, and so did touch on this the other day, now if we're getting x on its own, we're going to have to divide by a negative number, right? Now when we're working with inequalities, what happens is when you multiply or divide by a negative number, I'll show you now why that is, but the symbol is going to have to change direction. Just on the side, I'm just going to show you quickly if we're working with numbers, right? Do we all agree, guys, that 4 is smaller than 5? If I had to read that, that is saying 4 is smaller than, the smaller part of the symbol is like pointing towards the 4. So 4 is smaller than 5. Do we agree with that? Right? That is true. 4 is definitely a number that is smaller than 5. Now guys, if I multiply through now by a negative 1, right? Which is what you would have to do here. You would have to divide by negative 1. So if I now multiply by negative 1 or divide by negative 1, I'm going to end up with a negative 4 on this side and a negative 5 on that side. But guys, is negative 4, don't write this down yet, but is this still true? Is negative 4 still a smaller number than negative 5? No, if you're thinking on the number line, right? You have negative 5, negative 4, negative 3, negative 2, negative 1, and then 0, right? So in this case, if I multiply or divide through by negative 1, the symbol has to actually change direction because negative 4 actually is a bigger number than negative 5. Okay, so that is what happens when we're multiplying or dividing by a negative number. I'm just going to write on the side here. Times or divide by. And it can be any negative number. It doesn't have to be negative 1. It's just the easiest one to show you. So when you multiply or divide by a negative number, then symbol changes direction. So that is something that you're going to have to remember with these types of questions. Okay, so you're treating it exactly as you would treat an equation, except for when you multiply or divide by any negative number, then you must remember to change the direction of that symbol. Okay, apart from that, it's exactly the same as an equation. Okay, let's quickly go back to, you guys still copying that down? Okay. All right, so now I have to divide by -4. Alright, so now I'm going to say x, and now instead of greater than or equal to, I now need to swap the symbol around. Smaller than or equal to -9/4. Okay, so let's just highlight that so that we remember what's happening there. This symbol has to change its direction when we are dividing by -4. Okay, let's quickly write it in the other notations as well. So x is smaller than or equal to -9/4. So we would have to say, I'm just going to put an or here. X is an element of. Now guys, if it has to be smaller than -9/4, is -9/4 still the smallest number? No, it's now going to be the biggest number, hey? So now we're going to have to say from -infinity to -9/4. And now we're going to use a square bracket because in the question there was a line underneath the symbol, meaning, that x can actually also be equal to -9/4. That will still make this equation or this inequality true. All right, so let's just add a note there. This square bracket, because x can be equal to -9/4. Still, -infinity has a round bracket because it's still not actually a number that it can be equal to. Okay, let's quickly do the number line. Again, we only have one value, so we're just going to put that one number on there. And guys, you can write it in decimal form if you want, or you can write it as -2.25. It doesn't matter. You can also leave it as 9/4. Okay, you don't have to change that. Now, since it can be equal to -9/4, we put a closed dot, right? So basically a point above that. So open if it's not equal to, right? If there wasn't that line underneath. Literally like a colored in dot if it can be. And now it has to be smaller than. So now my arrow is going to go to the left hand side of that number. All right, last example, number 3. Are there any questions on that one, guys? Oh dear, sorry. Oh dear, I forgot to plug in this thing. Let me just quickly. Okay. All right. Thank you. Okay, number 3, we're quickly going to do one where you have two, like the x's in the middle, and you have a number on either side. So we're going to start with -5 on this side, and then smaller than or equal to, we have a 1 minus 3x in the middle, and then again smaller than or equal to, and then 10. Now guys, what they've done here is they've basically given us two inequalities in one, right? What I can do is I can just ignore that 10 and I can solve that inequality, right? What would I do with the 1 if I have to move it across? I would -1, and then I would have to divide by -3. But what about this one? Wouldn't I do the exact same thing? What would I do with this one? I would again -1, and then again I would divide by -3. So guys, instead of doing the same thing more than once, I don't know if that makes sense, like in separate steps, we're going to subtract 1 from both sides at the same time. And then we're going to divide both sides by -3. Okay, so what we're going to do here is we're going to say, what's -5 minus 1? -6. I'm going to be left with that -3x. But remember, I must do it on the other side as well. I'm solving two inequalities at the same time. So what is 10 minus 1? That is 9. Okay, so I'm just going to write on the side here, subtract, subtract 1 from both sides. Okay, to get x on its own now, I need to divide both sides by -3. But guys, remember, I'm now dividing by a negative number, so I'm going to have to change the symbols. Okay, remember, when we divide by a negative number, we change those symbols. So what is -6 divided by -3? +2. Now, instead of smaller than or equal to, remember, I divided by -3. I need to change it to a greater than or equal to. Okay, so that symbol must change. I'm just going to be left with an x. Remember, I must do the same thing on the other side. I have to say 9 divided by -3. So again, I'm dividing by a negative number. This symbol must change. So that is also going to become a greater than or equal to symbol. And what's 9 divided by -3? -3. All right, so here, divide both sides by -3. And then I'm just going to put in brackets, remember to change symbols. Guys, unfortunately, what we have now, this answer is correct, but it's not written correctly, because just like interval notation, with inequality notation, you also always have to put the smallest number first. Okay, so do you see that we have a 2 on the left here and a -3 on the right? That's not how numbers work. Okay, the -3 must actually be written first. So just put a therefore, and I want us to put a therefore so that you know that we're not actually doing anything more in terms of like solving it. I'm just rewriting the answer in the correct way. I actually need to put the -3 first, the x in the middle, and then the 2. But now, guys, we just need to pay attention to those signs, okay? Because the -3, if we're reading it from the -3 to the x, which is what we're going to do here, hey? What is this saying? -3 has to be smaller than or equal to x. So -3 has to be smaller than or equal to x. Do you guys see what I'm doing? It's almost like you're taking the whole inequality and you flipping it completely. All right, so you're changing the order of the numbers, so the signs must actually also change. Let's quickly look at the 2. It's saying from the x to the 2, hey? It's saying x must be smaller than or equal to 2. So x must be smaller than or equal to 2. Alright, you can't just change the numbers and keep the symbols as they were. Okay, just check that again. If you wanted to read this in an easier way, for me, I always say I'm reading it from the inside out, right? So from the x out to the numbers. This is saying that x must be smaller than, because the smaller point of the symbol is pointing towards the x, right? X must be smaller than or equal to 2. Is that still saying this here? X is smaller than or equal to 2. Okay? And what about the -3? X has to be greater than or equal to, because now the open part, right, the bigger part of the symbol is facing the x. So x has to be greater than or equal to -3. Is that still saying that here? X has to be greater than or equal to -3. Okay, so guys, you can think of it as if you're almost swiveling everything around the x. Okay, that 2 you're taking to that side, and then you also have to like change the sign. Okay. So that is inequality notation. I'm just going to write here underneath. Smaller number first. Okay, very important. You're going to lose a mark if you don't do that in a test or exam. You always have to put the smaller number first. Alright, let's quickly do interval notation for this as well. We're going to say x is an element of... Guys, am I now going to use infinity or negative infinity in my interval? No, hey, this is saying x must be bigger than or equal to negative 3, but also smaller than or equal to 2. So basically, x has to lie between negative 3 and 2. That's actually what this is saying. X is between bigger than negative 3, but smaller than 2. All right, so a number like 0, for example. Any number that is between negative 3 and 2. So we're going to put, again, a square bracket, because in the question, it's given that it can be equal to negative 3, so square bracket. Then we use a semicolon, and the bigger number is going to be 2. Can it be equal to 2, guys? Yes, because of that line underneath the symbol. So again, we are going to use a square bracket. If you had to draw this on a number line, this one is now slightly different. You're going to do negative 3, and you're going to put a 2, right? So the two numbers that you have. You're going to put a dot above both of those numbers, depending on whether it's being included or excluded. Can it be equal to negative 3? Yes, so negative 3 is included in the solution. That's what I mean when I say included, right? If you had to list all the numbers that x could be equal to, negative 3 would be one of those numbers. Okay, because they're saying their x is equal to negative 3. And what about 2? Can it be equal to 2? Yes, so we use a round circle again. Guys, they can give you one of each, hey? They can give you like a line underneath the one symbol and no line underneath the other. Okay, so you need to make sure. It's not always going to be 2 square brackets or 2 round brackets. It can be a square and a round. Okay, it depends on the question. And now x must be in between these two numbers. So what we're going to do is we're just going to draw a line connecting those 2 points. All right, how are we feeling? Does that make sense? Okay, I'm going to give you some of these to practice now. So exercise 4.12. Page 98. Right, I would like you to do numbers 1 to 8. Quickly copy that down so that I can put the questions on the board for you.